Hey, statistics. Here we go with section 2.6. It's about the least squares regression line. That is the y hat equals a plus bx best fit line that we've been talking about. But I'm going to explain today why it's called the least squares regression line. And then most of what we're doing is with the calculator today. Okay, the best fit line is called the least squares regression line. Least squares regression line. We get tired of saying least squares regression line, so we will start saying LSRL, least squares regression line, because it's too much to say and too much to write. It is the line that makes the sum of the squares of the residuals the smallest it can be. Now, what does that mean? The sum of the squares of the residuals. In the first place, a residual, this is a review from before, it's y minus y hat. It's a y value from a data point, xy, minus the y value from putting an x value into the equation and getting a y hat. So that's on the line. All right, here's what we're going to do. I'm going to make two scatter plots and kind of explain what this sum of the squares of the residuals thing means. Okay, I'm going to make two scatter plots. I want to have the exact same scatter plot. Okay, so there's those 4 points. And I'm going to come over here and I'm going to try and make the exact same 4 points happen. So try that. Make just about the exact same scatter plot. And now I'm going to do two things. I'm going to make a bad line for the line of best fit. I'm going to make a good line for the line of best fit. Ready? Here we go. That one is good. So this is a good. Y hat equals a plus bx. And then we're going to do one that's real bad. All right, ready? Watch this. We'll go like that. There's no way that's the line of best fit. So this is a bad. Y hat equals a plus bx. I'm going to draw on here what I mean by the sum of the squares of the residuals. In the first place, I will just draw what we mean by a residual. A residual is an error. When I go to make a prediction, like here's an x right here, I'm going to put x right there. If I put this x into this equation and get a y hat, it's going to be here, right? And that is definitely not what the actual y was, so I missed by that much. That's a visual representation of a residual. So look, I'm going to draw these vertical lines to hit my best fit line. Now, the reason I square them is because some are positive and some are negative. If I go this y minus y hat is on the line, that y minus that y is going to be positive. But this y minus y hat is going to be negative. So I square them to make all of them positive so I can make some kind of number. But look, when you square a distance, doesn't it become an actual square? Right? 3 squared is 9, and this would have an area of 9. It's a geometry trick. So I'm going to make squares out of all these distances, and let's talk about the sum of these squares. Well, this one's going to be really big. They'll overlap a bit. That's all right. If I added up all 4 areas, I would get a number. Now look, this line of best fit goes through the scatter plot better. So let me draw all my vertical distances. Those are the residuals, y minus y hat. Some are positive. These two are positive. These two are negative. Now make squares out of them. And you guys will see visually that if I were to add up those 4 areas, it would be a lot smaller than if I add up these 4 areas, right? So when the line is the best it can possibly be, it will be the line that makes the sum of all those squares the smallest it can be. That's what we mean by least squares regression line. The equation for this least squares regression line is, of course, the y hat equals a plus bx. Okay, let's go to the second page here. And before I end the video, I'm going to put a little bit more notes here, and then I'm going to ask you guys to do something, okay? So go to the second page, and here are the steps to finding a least squares regression line on your calculator. Enter the data points in L1 for x and L2 for the y variable. Then you hit stat once they're in there, and you arrow over to the calc menu, right? So there's a calculator. I put my data into edit. I put list 1 and list 2. That's what I do. Then I hit the Stat button and I go over to the Calc menu. Okay? And then what do I do next? I hit 8 for linear regression a plus bx. I'm going to bring the calculator back over so you can see it. I go over to calc and then I go down to number 8 for linear regression a plus bx. I'm going to make sure that this x list is list 1 and y is list 2, and I just go down and hit calculate, and the calculator does a little work and it tells me the equation is y equals a plus bx. It tells me that a is negative 2.64 and b is 0.06, so I could write my equation. It also tells me what the correlation is. Make sure the x list is list 1 and the y list is list 2, and hit calculate, and you are good to go. Now, let's, for those of you who have calculators that are a little older, when you hit stat and go over to calc and hit number 8, it won't give you this drop down menu. It just goes, I'm going to hit, I don't know if, let me try something here. I'm going to hit second and enter. There it is. So when you guys have the older calculator, it'll just bring this up. And it's waiting for you to tell you what lists. So you have to type in list 1 and then a comma, which is right here above the 7, and then list 2, and your calculator will look like that. And then you hit enter, and it will give you all of that information. Okay? So here's what I want you guys to do. Go to page 139. On page 139, we've got miles driven and price for a car. Okay, so this has to do with, I think we did this in class the other day. If there's a certain miles driven on a car, it's going to be worth a certain amount of money. And so we're going to put miles driven in list 1, and we're going to put the prices in list 2, and then I want you guys to find the least squares regression line. So do that now.